this part of the tutorial, you will learn what it means to actually quote our code. Let's have a look. But first, let's have a look at normal R code, just to explain you the difference. Normal R code can be like that. You have two objects right here, A and B. Both of them contains three numbers. And what you do here is you just add them up and then calculate the sum of the elements which are the result or the outcome of A plus B. And this is actually something which is really typical for normal source code. So what you actually provide to the sum function is not A plus B, you rather provide the outcome of A plus B to the sum function. So what you do first is you calculate what A plus B actually is, which is 2, 3, and 4, and after that you take this and deliver it to the sum function, which does something else with it, namely it adds all these numbers up. So first thing is you calculate, you evaluate the expression which is highlighted in blue right here, and the outcome is then submitted to the sum function. And the sum function does not even know, and it's not important for its proper function to know whether its input is actually the result of another calculation or whether you use the numbers itself as an input. So you could also write C, 2, 3, and 4 and put it in sum. This would lead to the same outcome, and the sum function is absolutely not aware which of the two cases is true. And this, what you see right here, is an example of normal code, of unquoted code, which is executed, which is evaluated as early as possible. So what is quoted code in contrast to that? Yeah, quoting is, first of all, it's a really important concept for metaprogramming or for non-standard evaluation. And unlike in the previous example, quoted code is not evaluated immediately. So you don't calculate A plus B as early as possible, but it's rather suspended or diffused or delayed or captured. I just listed different expressions for what happens inside this bracket. So, but what it's all about is there is no immediate execution, but what you do is you provide to the function the actual R code. So what you provide is not 2, 3, and 4 like in the previous example, but rather the source code itself. And the source code is A plus B. And why do you do it? You do it because the function which receives the source code can examine the source code, so have a look at it and make some decisions based on what it finds in there. It can modify the source code like shown in the introduction, or it can also evaluate it. So after doing these two steps, it's still possible to evaluate the source code and get the result, namely 2, 3, and 4. The evaluation can either happen in the environment of a function, for instance, or in any other environment. It's really up to you, but we will talk about it in more detail in the evaluation chapter. But the thing is, you have to keep in mind is that now you don't provide the result, you don't evaluate, but what you do is you provide the source code itself. So, and how do you do it in R? Because what I explained to you before was rather theoretical. You can do it in two ways. And which of the two ways you have to choose really depends on the context or where the source code is. If the source code is outside a function, you have to use case 1, and if it's inside a function, you have to use case 2. Let's start with case 1. So you are not in a function. And if you're not in a function, you have to use the expression method, the expression function, which is part of rlang. And what you do is you put the actual expression or the code you would like to quote. It can be as complicated as you need. You can just put it inside these round brackets and store the outcome, for instance, in an object. I called the object quote1 here. And by looking what is inside, by printing it, you see that now you have A plus B inside of it. And what you now have to see and really have to be careful about. A plus B is not inside quotation marks like you would expect it from a string. There are no quotation marks, and because there are no quotation marks, it's actually a quote. Sounds a little bit strange, but it's the way it is. So because you don't have any quotation marks before A and after B, this means that it's quoted code. So this means that it's really the code itself. And now let's come over to case number 2. Case number 2 becomes relevant when you are inside a function. And we have an example for that right here. So we have a function which I called iQuote, and which I created in these 4 lines. And in the 5th line, I actually execute the function. This function has a parameter vQuote, and as an input for vQuote, I put in some source code, so a plus b. Similar to how I did it with the sum function, where I also executed it and told that a plus b as the actual input. And what I do right here in the function is I use an expression. And an expression sounds really similar to expression, but the difference is really that now the input is not source code itself, but it's rather a function parameter, we quote here, which contains some R code, or which is supposed to contain some R code. And by capturing it, storing everything in an object, expression quote, and printing it, you see that the outcome is the same as in the previous case. So what you really have to do is you have to distinguish between these 2 cases. If you are outside the function, you see there's no function here at all, like here, you have to go for case 1. And if you are inside the function and the provided quote is provided using this parameter here, you need to use an expression. But in both cases, there is no immediate evaluation, but rather the source code itself is captured for further analysis. And see, in both cases, like shown here, there are no quotation marks. And now you could ask, okay, what happens if we mix up these cases? What happens if I also use expression inside a function and not an expression? And the answer to that can be found on this slide. So you see here I use expression instead of an expression. The rest is still the same. And now you see that the outcome is different. Now the outcome is the quote and not actually a plus b or a multiplied by b. And the reason for that is simple. Expression really just takes what is inside these round brackets and does not look inside. In case of a function parameter, in most cases this does not make sense, because you are in most cases not interested in this name and capturing this name, but rather to capture what the user has provided as an argument value. And in order to do that, you have to use an expression, like I showed to you on the previous slide, and then R actually looks what is inside this parameter, what was provided by the user, and in this case everything works as you've expected it.